Right, hiya, welcome to another maths video. This is a really interesting question. The kind of format of the question is one that I found through a different channel. I'll link that channel in the description. And from that channel, I kind of found this problem, a problem with the style, found a really helpful method that I hadn't come across before. And I'm going to use that method in this video to help find all integer solutions for A and B. I'm pretty sure there's only one pair of solutions. Well, one pair of integer solutions, I should say. But there are questions of this mould where there are different integer solutions. In fact, I think the video that I found this from, there were 3 pairs. But I've just written this one just as a way of kind of making it my own. And just so I can kind of go through the method in a nice way. So if we go to the next, if we get on the next slide, so we've got 5a plus 5 over a plus 4 over b equals 7. So the first thing we're going to do is bring the two denominators up. So let's firstly deal with this a. We need to times everything by a, and times this by a, times this by a, and then times this by a. So with the first one, the a is clear, and we're left with 5 plus 4a over b equals 7a. And obviously we've still got this b as the denominator, so we're going to multiply through by the b. So we're going to multiply by b, multiply by b, and then multiply by b. So with the second term on the left-hand side, the b's are going to cancel. And now we are left with 5b, sorry. Let's just get rid of that. We're left with 5b plus 4a equals 7ab. That a is terrible, please just ignore it. So at this point, you're probably thinking, well, no, they're still not very helpful. You know, what can I really do with that? Just plug in numbers and just hope for the best. You can do. Trial and error is perfectly valid. Might take you a little while, but you know, it is perfectly valid. Just plug in as many numbers as you can just think of and just try for the best. But the problem is you can't definitively say that you have tried every feasible integer. If you just plug in, you can plug in 0, you can plug in 1, you can plug in 2, you can plug in 3. Well, we can say that a and b cannot equal 0 because the original equation becomes undefined. 5 over 0 plus 4 over 0, that becomes, for all intents and purposes, infinity, and we can't work with that. So we're left with this. We know it can't be 0, so let's do a little bit more playing around with it. You're not expected to be able to know this method just off the top of your head. Like I said, I wasn't aware of this method, but I found it really interesting. So the next step is to bring everything over to the left-hand side. So if we kind of bring this down, we say that 5b plus 4a minus 7ab equals 0. And now we want to find a common factor. So let's say this first one, this 5b, and so it doesn't have anything in common with the 4a, nothing that's worthwhile taking out. But this minus 7ab, both of these terms have a b. So we can bring the b out as common factor. So we bring b out, that b, and we say 5 minus, so we got 5 here, and this is then what's left from the second term is the minus 7a. And now we're just left with 4a equals 0. Now this next part is the really cool part, I think. So we want to recreate this bracket. We want to have two terms here that when we bring out a common term, we're left with that bracket. So if we wanted minus 7a, from this 4a, we would take out minus 4 over 7. Because if we have 4a, we can split that up into minus 4 over 7 multiplied by minus 7a. And then when we put them together, we get the original 4a. So here we don't use a plus, we get rid of the plus. We say minus 4 over 7, and then we just say minus, it would help if I wrote the numbers down correctly, minus 7a. Eventually, I'm going to be using a camera and a whiteboard for these, but just for now, you're going to just have to do with me trying to write things out on a PowerPoint slide, and just take it from my words to understand what things mean if the writing isn't exactly clear. I'm doing my best. I'm using a mouse. So now we've got the minus 7a, but we're missing the 5. We can't just we can't call these two things identical until we have a little 5 there as well. So we need to add something that when we bring out minus 4/7, we're left with 5. So again here, we need something that when you multiply 4/7 by it, some unknown number, we get 5. Well, if we just solve for a, bring the 7 up, bring the 4 down, we're left with 35 over 4 minus, and then when you multiply that by 4/7, negative 4/7. In fact, no, we want it to be positive inside the bracket. So in fact, I'm pretty sure I've done this the wrong way around. Let's get rid of this, because we're not looking to solve inside the bracket. We know what we want inside the bracket. We're looking to solve outside the bracket. So we know that when we take minus 4 over 7 and we multiply it by positive 5, we get the thing that's going to be outside the bracket. So when we bring out minus 4/7 as a factor, we're left with 5. So we just multiply these two things together, we get minus 20 over 7. So if we rub out this bracket here, and we just we do our plus 5, but whatever we add to the left hand side, we have to add to the right hand side. So our 0 that this was all equaling, we add to that side, well, we subtract minus 20 over 7. Okay, let's rub out this bit of working. You can go back and pause it if you need to, or you can just go back and go over it again if you need to go over it again. So at this point, we have our new equation. And at this point, we can bring out 5 minus 7a, or minus 7a plus 5, you know, they're both the same sign, they're both the same thing, as a common factor. And what are we left with? We are left with, so 5 minus 7a, we're left with b minus 4 over 7. And this gives us minus 20 over 7. Now, you're probably thinking, well, this is still really ugly, still not really very workable. And to that I say you're right. So we're going to do a bit more playing around. We're going to get rid of the denominator again. So we're going to multiply both sides by 7. Obviously these two things clear. And this 7 we're going to put straight into this bracket. Because if we put it into the first bracket, we're just going to get bigger numbers. If we put it into the second bracket, we're going to be clearing a denominator. So 7 times b is 7b. 4/7 times 7 is just 4. So now we have put that through, we're left with 5 minus 7a and minus 7b minus 4. Still, one thing we can do just to make our lives a little bit easier, we can get rid of the negative, so we're going to times both sides by minus 1. We're going to make this a plus, and let's make the bracket with the negative a positive. So let's make that a negative, make that a positive. So now, if we go to the next slide, we have a bracket which is 7a minus 5, and we have 7b minus 4. Let's get the pen back up. We have 7b minus 4, and this equals 20. So at this point, it looks a bit better. It looks a bit more appealing on the eye. And also at this point, we can say, right, we want these two numbers to be integers. So at this point, all we have to do is we have to gather pairs of factors, pairs of factors of 20, pairs of numbers, and multiply together to get 20. Integers, though, because we are looking to solve from we're looking to solve each of these brackets given that they're a value of a number. If we have a fraction, then it's just going to get complicated. It's going to get awkward. Like I said, take my word on it. We're going to need to find out pairs of numbers that make 20. So here, essentially, we have a number multiplied by a number that equals 20. And we are going to give these numbers values. We can go through all of the list of integer values that multiply together to get 20, positives and negatives, and then we can just go through them, see if we get A and B to be integer values, and then if we do, we know that we have gotten the right either one solution or more than one solution or 0 solutions. I mean, I've already told you that there is going to be at least one solution. In fact, I've told you that there is one solution. But let's go through the rigmarole. So at this point, we need our pairs of numbers that make 20. So let's go 1 and 20. Let's go 2 and 10. Let's go 4 and 5. That's not very good. 4. And then we want the reverse. We want 5 and 4. Because these two brackets are different values, so it could work for one way and not for the other. And in fact, I'm pretty sure it will. We will see that as we go through. We want 10 and 2, and we want 20 and 1. We want those numbers as positives, and we want each of those numbers as negatives, because a negative times a negative can become a positive. So let's put these numbers in. And the nice thing is, we don't have to put in both pairs of numbers. If the first number comes out as a non-integer, we can just say, right, we have one non-integer, therefore they can't both be integers if one of them is a non-integer. We can just stop right there and go on to the next one. So let's take our number 1. Let's equate this bracket here to 1. So 7a minus 5 equals 1. Well, we can solve this and we get a as 6 over 7. This is not an integer, therefore we ignore this particular number. We don't have to try the 20 either. I mean, we can say that 7b equals minus 4 is 20, 7b is 24, b is 24 over 7, and that doesn't work. So now, let's try the next one. Let's try this equaling 2, and then this equaling 10. So 7a minus 5 equals 2, 7a equals 7, a equals 1. So we have a number that works. We have a equaling 1, and then let's try this. Try the second one. 7b minus 4 equals 10. We add 4 to both sides, we get 7b equals 14. And then we get b equals 2. So we have a pair of integers that work for this equation. We have a equals 1 and b equals 2. Now we can just kind of pace through these other numbers. 7a minus 5, let's do this 4 and 5 here. 7a minus 5 equals 4, we add 5 to both sides. 7a equals 9, 9 is not a multiple of 7, we don't get integer solution. Now we equal that left hand bracket to 5. 7a minus 5 equals 5, we add 5 to both sides. 7a equals 10, not a multiple of 7, we don't get an integer solution, we go on to the next one. 7a minus 5 is 10, we add 5 to both sides. 7a equals 15, 15 is not a multiple of 7, so we can't get a fat integer solution. And then 20, 7a minus 5 is 20, 7a equals 25, again, not a multiple of 7, we can't get an integer solution. Now we've done our positive pairs of factors, and we've seen we only have one of them that works. Now we need to go through the negative factors. So we say that 7a minus 5 equals minus 1. We add 5 to both sides, so 7a minus 5 equals minus 1. 7a equals 4. We don't get an integer solution, so we can discount that. Minus 2, we add 5 to both sides. 7a equals positive 3, no integer solution. 7a minus 5 equals 4. 7a minus 5 equals minus 4. 7a equals 1, we don't get an integer solution. 7a minus 5 equals minus 5. 7a equals 0, therefore a equals 0. And then that works. You plug b in as 4 again, you get 0. So 0 and 0 work for this bracket, but when we go back to the original solution, we said earlier that a and b cannot equal 0 because we get undefined terms. So unfortunately, that doesn't work. And then the next one, minus 10, 7a minus 5 equals minus 10. 7a equals minus 5, a equals minus 5 over 7, not an integer solution. Get on the next one. And then last but not least, 7a minus 5 equals minus 20, 7a equals minus 15, not a multiple of 7, so we can discount it. So we only have our one pair of numbers, one pair of integer solutions for this. We have a equals 1, we have b equals 2. When we plug in this as 1, we get 5 over 1, which is 5. We plug in b as 2, we get 4 over 2, which is 2. 5 plus 2 does indeed equal 7. And that is the answer to this. Thank you for watching, I hope it helped, and I'll see you for another maths problem next time.